Alright, welcome guys. Thank you for tuning into this channel. I'm going to contribute a little to whatever Parvesh sir has been doing, and he is doing a phenomenal job. He is doing a phenomenal work to help all of you study in whatever way you guys could. Anyways, so here I'm going to help you solve a couple of numericals. I've got here a couple of numericals that have been asked in previous year question papers. Let's go with this one. It says a point charge plus q is placed at the centroid of an equilateral triangle. When a second charge plus q is placed at a vertex of the triangle, the magnitude of the electrostatic force on the central charge is 4 Newton. What is the magnitude of the force on the central charge when a third charge plus q is placed on another vertex of the triangle? I'm going to repeat this question just in case if you want to note this question, you can pause at any point of time. You can note the question along with me. I'm going to repeat this question. It says a point charge plus q is placed at the centroid of an equilateral triangle. When a second charge plus q is placed at a vertex of the triangle, the magnitude of the electrostatic force on the central charge is 4 Newton. What is the magnitude of the force on the central charge when a third charge plus q is placed on another vertex of the triangle? The options given are 0, 4 Newton, 6 Newton and 8 Newton. Now this question is fairly simple, and there are a couple of ways to solve this numerical. I'm going to help you solve it in the most easiest way. I'll try my best. So here's how it goes. So according to the question, assume that we have an equilateral triangle over here. Alright, so let us assuming that we have this equilateral triangle. Consider that this is the centroid and a positive charge plus q is kept over here. There is another positive charge on one of the vertex, and you have been said that the force, and of course they both are positive in nature, so of course there is going to be force of repulsion. So this positive charge plus q and this positive charge plus q, they are going to experience a force of repulsion. The force is given to you as 4 Newton. Now the second part of this question says that there is one more charge that can be kept on any of the vertex. So let us assume that we have kept it over here. Now this is an equilateral triangle. If we assume that this distance is a, we know the formula for force that says 1 upon 4 pi epsilon naught q1 q2 upon r square, where r happens to be the separation between the two charges. 1 upon 4 pi epsilon naught is a constant. Its value is 9 into 10 raised to 9 by magnitude. Here q1 and q2 means the system of the charges, the two charges over here. In this case, if there is this charge plus q, here is one more charge plus q, the distance between them is a. Automatically, and you can by default understand that this distance is also going to be a, because it is an equilateral triangle. You understand that if this is the centroid, this is the vertex, if the distance between them is a, so in this case, if this distance is a, this distance is also going to be a. So the separation is same. So now you understand that the separation is same. 1 upon 4 pi epsilon naught is a constant, so it is also not going to change. Now talking about the system of charges. In the question you have been given that these two charges hold equal amount of magnitude, and even here you can say this is also plus 1q, this is also plus 1q, this is also plus 1q. So the system of charge over here is plus 1q and plus 1q. Over here it is also plus 1q and plus 1q. So this is also same. So now if you see in this equation, the separation is not going to change, the constants are not going to change, the system of particles are not going to change. So if all the parameters on the right hand side of this equation do not change, we automatically understand that this force is also going to be the same. So if there is a force 4 Newton over here, this force is also going to be 4 Newton. So now there are a lot of methods, you know how to solve this. So you can consider that there is a 4 Newton force over here, there is a 4 Newton force over here. You can use parallelogram method and you can solve it, because you now understand that the angle between them is 120 degree. But in entrance exam, the logic is to save as much time as we can. So we are going to solve it in a better way, in another way. We can see if we could save a little bit of our time. What if I assume that at this point there is a combination of this charge plus q minus q? that is ultimately going to be 0. That's what the question is. So currently here is a plus q charge, here is a plus q charge, here is a plus q charge, and here is a 0 charge. So if it is 0 over here, I can assume as plus q and minus q, and if I assume it like this, then this entire system that you see is going to create a net force of 0 Newton. This plus q is going to apply 4 Newton force over here. This plus q is going to apply 4 Newton over here. This plus q is going to apply a 4 Newton force over here, and the net force on this centroid, because of all these plus q, will be 0. The only force on this will be due to this minus q, and by default we understand that plus q minus q, there has to be a force of attraction. Since the magnitude are same, the distance between the separation between them is same, so of course the force is going to be same, and without solving you can figure it out that the answer is going to be 4 Newton. So that happens to be the right answer, that is 4 Newton. So without any solving, without any doing a calculation, just by logic you can solve this numerical. All right, I hope you understood this numerical. I'll put this aside. I want you to check this numerical and see if it helps you. All right, thank you.